This is Precalculus video lecture number 17 on polynomial and rational inequalities. So in this lesson, we're going to look at how to solve polynomial inequalities. And just keep in mind, inequalities are more temperamental to deal with than solving typical equations. You'll remember when you're just solving a regular linear inequality, if you multiply or divide by a negative, you need to reverse the direction of the inequality sign. And our zero product property does not hold for inequalities. So a times b less than 0 is not equivalent, to a less than 0 or b less than 0. So what do? Here are the steps to solve a polynomial inequality. So you want to get 0 on one side of the inequality, usually the right side's the easiest, and then solve the polynomial equation by factoring. So you're basically going to pretend there's an equal sign, find the zeros, find the x-intercepts. Once in a while, it won't factor, so in which case, don't forget about the good old quadratic formula, should you need it. Okay. Then you're going to use the numbers found in the first step. You're going to use the zeros to divide the number line into intervals. I'll show you exactly how to do that. And you're going to test points from each interval in the inequality. If it's a true statement, then that means the interval is part of the solution set. If it's a false statement, then the interval is not part of the solution set. And then your final answer, you just union up all of the intervals that came out to be true. Okay, this will make a lot more sense later, but just so you have an idea of the process, there it is. And here we go. Solve the inequality and then express the solution in terms of intervals. So they want all of the answers given in interval notation. All right, the first one's pretty much set up for us because we already have a 0 on one side of the inequality and it's factored. I mean, what more could you ask for? So we're going to make a number line and I'm going to list the zeros from each of the factors on the number line. So the zeros are going to be +1 and -4. All right. Now notice here, these two zeros have divided up the number line into 3 intervals. What are these intervals? Let's zoom in a little bit. So the first interval goes from -infinity to -4. And since, notice this is a strict inequality, strictly less than 0, then I'm going to put parentheses on the -4. We're not including it. The next interval is from -4 to 1. And the last interval is from 1 to +infinity. So now what I'm going to do is test each of the intervals to see whether or not they satisfy the inequality. You can test any number that's in that interval, never test using the endpoints. So say for this first interval from -infinity to -4, I'm going to test with x equals -5. Doesn't matter, -5, -6, -4.1, it'll all come out the same. What you're going to do is test -5. You're going to plug that in for x into the factored form of the polynomial on the left-hand side. And you actually don't need to know what number it comes out to. You just need to know whether or not it's positive or negative. So watch what I mean here. So if I plug in -5 into this first factor here, into x minus 1. -5 minus 1, that's going to be negative. And then -5 plus 4 into the second factor, that's also negative. So a negative times a negative means I'm going to have a positive value if I substitute in x equals -5. Now ask yourself, is this a true statement? Will this satisfy the inequality? Are positive numbers less than 0? No, they are not. So that means nothing in this interval will work or satisfy the inequality. So you only have to test one value, and it's basically the representative value for everything within that interval. Okay, moving on. Now let's test the next interval. So what lies between -4 and 1 that you want to test with? I like 0. That's a nice one to test with. Okay, so 0 minus 1, if I plug in 0 into that first factor, that's going to be negative. And then 0 plus 4, that's going to be positive. And we know a negative times a positive, that's going to give us something that's negative. Are negative numbers less than 0? Does that satisfy the inequality? It sure does. So that interval in the middle works. All right, good. last one, now we're going to test the interval from 1 to infinity. So pick something in there. You could pick 2, 7, 43, doesn't matter. So x equals 2. 2 minus 1, that's positive. 2 plus 4, that's also positive. And a positive times a positive is positive. Are positive numbers less than 0? No, they are not. That means nothing in this interval will satisfy the inequality. So the only interval that works that I'm going to report for my solution is the interval from -4 to 1. Okay, and then you can just box it if you want. Don't put a solution set around an interval. So you use these squigglies, right, the squiggly brackets. For solution sets, that's when you're writing in set builder. But if you're writing in interval notation, you don't use it. So don't mix them together. Okay, let's look at another example. This one we have a little more work to do because remember we need a 0 on one side of the inequality. So we got to move that -8 over to the other side. Let's do it. So we have x squared plus 6x plus 8 is greater than 0. And then this one factors, how fantastic. So we have x plus 4 times x plus 2 is greater than 0. Now I'm going to make my number line and then list the zeros on there from the number line. So we have -4 and -2. Okay, very good. Again, we have 3 intervals here. Let's list them out before we get started. So this first interval is from -infinity up until -4. Now would I put parentheses or a bracket on -4? How do you know? You look back here at the inequality sign. Since it's a strict inequality, it's just greater than 0, not greater than or equal to, then I put parentheses. We're not including -4. Next interval is from -4 to -2. And then the last one's from -2 to infinity. Okay, very good. Let's see. So from -infinity to -4, let's just test with -5 again. And then imagine, -5 plus 4, that's negative. -5 plus 2, that's negative also. So I'm going to get a positive number for anything that lies within that interval. Will that satisfy my inequality? Well, look, this time I'm looking for something to be greater than 0. Are positive numbers greater than 0? They are. Yay. So that interval works. Good, good. Let's look at the next interval from -4 to -2. What do you want to test in there? We can use -3. X equals -3 is in there. So -3 plus 4, that's going to be positive. -3 plus 2, that's negative. And a positive times a negative is negative. So will this interval work? We'll go back to the original inequality, and notice here we're checking if it's greater than 0. So are negative numbers greater than 0? No, they are not. That means nothing in this interval will work. Okay, last interval is from -2 to infinity. What do you want to test with in there? I say how about x equals 0? That's always such a nice one to test with when you can. Okay, so go back to the factored form. 0 plus 4, that's positive. 0 plus 2, that's also positive. A positive times a positive is positive. And positive numbers are greater than 0, so that works. So this time we actually have 2 intervals that satisfied the inequality. So when you write out your final answer, you're going to union them up, join them together. So you would list it as -infinity to -4 union -2 to infinity. Okay. Good. I actually love this whole process because it's just fun putting plus, minus, and you don't have to actually plug in the values. It's not so tedious. It's just kind of fun. Okay, let's look at another example here. X minus 2 squared times x minus 3 times 1 minus x needs to be less than or equal to 0. Okay, let's see here. So let's make our number line. This time we have 3 zeros to list on it. Thank goodness they factored it already for us, right? That was quite kind of them. Okay. So what are the zeros? Positive 2, positive 3, positive 1. So 1, 2, 3. Okay, so the first interval, this is a little different. The first interval is going to go from negative infinity up until positive 1, and this time I'm including it. Why am I including it? Because look at the inequality. This time it's inclusive. It's less than or equal to 0. So I'm going to include the zeros when I list the intervals. Okay, next interval is from positive 1 to positive 2. And then we have positive 2 to positive 3 and positive 3 to infinity. Okay, looks good. Now let's start testing. So from negative infinity to 1, we could test with x equals 0, right? Okay, if I plug in 0 for x, actually it doesn't even matter. Anything in that first term is going to be positive, right? Because you square it. Great, so that one's positive. 0 minus 3, that's negative. And then 1 minus 0, that's positive. So I have a positive times a negative times a positive. That's going to be negative. Does that satisfy the inequality? Are negative numbers less than or equal to 0? Yes, so that interval works. Okay, what about the interval between from 1 to 1.2? How about using x equals 1.5? Okay, well, we already talked about it doesn't matter what goes in here for x, we're squaring it, so everything's going to be positive from there. 1.5 minus 3, that's negative, and then 1 minus 1.5, that's negative. So I've got a positive times a negative times a negative. That's positive. Does that work? Are positive numbers less than or equal to 0? No, they are not. So this interval does not work. Good. Next interval from 2 to 3. Let's test with 2.5. Oh, a lot of the time students will say, oh, why can't I test with 2? This time it's inclusive. But no, if you plug in one of the zeros into the inequality, you're just going to get 0 is less than or equal to 0. So it's not going to tell you whether or not that interval is part of the solution set. So regardless of whether or not the inequality is inclusive, don't test with one of the endpoints of the interval. Okay, 2.5. So first factor is going to be positive. 2.5 minus 3, that's negative. And then 1 minus 2.5, that's negative also. So positive times a negative, this is positive. Will that work? Is that less than or equal to 0? No way. So this interval does not work. And then last one's from 3 to infinity. So say we're going to test with x equals 3.5 or 4, doesn't matter. Let me clean this up. So if I plug in 4, I'll get positive times a positive, and then 1 minus 4 is negative. So this is going to be negative. Are negative numbers less than or equal to 0? Yes. Okay, so it looks like only the interval from negative infinity to 1 and from 3 to infinity satisfy the inequality. But notice something we forgot. We forgot a solution. So negative infinity to 1 union 3 to infinity is missing something. This is not the answer. I'm so sorry. Look back at the inequality. It says less than or equal to 0. So we need to include all of the zeros, not just the values that make the inequality negative. And notice here, 2 is a 0. It would, if I plug in 2 for x, I would get 0 squared times, and then who cares, is less than or equal to 0, which is true. So even though the interval from 1 to 2 and 2 to 3 didn't work, what about 2 all by its lonesome? You have to include it. So here's how you would write it up. You would say, okay, the interval from negative infinity to 1 is part of the solution set. And then how do you list just 2 all by itself? In a set. Yes, poor little 2. You don't write an interval because you can't include any additional value. So it's just 2 all by himself. Union, next interval is from 3 to infinity. There's your answer. Okay, watch out for that one. Wow, kind of tricky. Good, good. Let's look at another example. Here we have 2x times 1 minus x times 2 minus x is greater than or equal to 0. Okay, so let's start off by listing the zeros on the number line. How nice, it's already factored. Are you appreciating those little things? Okay, so we've got 0, -1, and +2. I always like to think about them before I start listing them so they're nicely spaced. Notice it's not to scale, and it doesn't need to be. I mean, you're just doing this for yourself to organize your math and your thinking. Don't put extra tick marks on your number line and confuse yourself besides the zeros. Okay, what are our intervals? So we've got negative infinity to -1. I'm going to include it. Why? Because this inequality is inclusive. It's greater than or equal to 0. Then the next intervals from -1 to 0, 0 to 2, and 2 to infinity. Okay, why don't you pause the video right here, see if you can test and figure out which intervals are part of the solution set on your own, and then I'll go over the answer in just a second. Okay, I hope you tried it for yourself. It's very fun. First interval, let's test with x equals -2. You don't need to list that. I'm just doing it to help you. Half the time I do it in my head and I don't write anything down. So 2 times -2, just think of this as like its own little factor, okay, if you want. So that's going to be negative. 1 plus -2, that's negative. And then 2 minus -2, that's positive. So negative times positive, that's positive. Is that what we want? Are positive numbers greater than or equal to 0? Why, yes, indeed. Okay, next interval from -1 to 0. What did you use? -0.5? So 2 times -0.5, that's going to be negative. 1 plus -0.5, that's going to be positive. And then 2 minus -0.5, that's going to be positive. So negative times positive, that's negative. Negative numbers are not greater than or equal to 0, so this interval does not work. It's not part of our solution set. All right, next one, let's test with x equals 1. That's between 0 and 2. I'm going to go quickly because you should have already done this. We have a positive times a positive, 2 minus 1, that's positive. This is also very positive. That works. And then last one, 2 to infinity. You can use x equals 3. So we'll get a positive times a positive. 2 minus 3 is negative. So this is negative. That does not work. That is not greater than or equal to 0. Okay, looks like everything got included, right? All of the zeros, -1, 0, and 2 are all accounted for. There's -1, there's 0, there's 2. So I don't need to include one value all by itself in the solution set like I did in the last problem. All right, so we have -infinity to -1, union 0 to 2. And that's it. Whoa, not what I expected or wanted. Here we go. Very nice. All right, I did promise you, though, we were going to also look at how to solve rational inequalities, and it's not too different, okay? Just a little bit more to consider. So here's the steps. You can change the inequality to an equal sign and solve the related equation. I actually don't like doing this. Don't do this. Find the numbers for which the rational expression is undefined. Yeah, that's important. Okay, I would say for the first step, find the zeros of the numerator and list them on the number line, okay? Find the numbers for which the rational expression is undefined. So also that's the zeros of the denominator. We know that. So you're finding the zeros of the numerator and the denominator. You're going to use those numbers to divide the number line into intervals. You're going to test points from each interval in the inequality, same as before. If it leads to a true statement, then it's part of the solution. If it's a false statement, then it's not part. Okay? Just keep in mind, if you have a zero from the denominator, that means the rational expression is not defined there. So it doesn't matter if the inequality is inclusive, you still would not include that point in your interval or in your final solution. I'll show you exactly what I mean, but that's just one like slightly dangerous thing that comes up with these guys. Okay, here we go. So solve the inequality and express solutions in terms of intervals. First one, we're ready to go. It's already got a zero on one side. There's no factoring to do. I can just look at it and say, oh, the zeros from the numerator are just 2, and then from the denominator, -5. You got to list everybody on there. You are not allowed to clear out fractions in an inequality if the denominator includes variables. Okay, normally in an equation it would be totally fine to do so, but you can't do it with inequalities. Remember, they're highly temperamental. Okay, so let's list the intervals out. Now check this out. This is going to be a little sneaky. So we've got -infinity up until -5. And then let me ask you this. Would I put brackets or parentheses here? Now, you actually need to put parentheses. And you're probably thinking, what in the world? It's less than or equal to 0. You said we put brackets if it's inclusive. Sure, but notice -5 is a 0 from the denominator, which means it's a restriction. So x is not allowed to equal -5. That would not be part of our solution set. So that trumps or basically overrules the fact that the inequality is inclusive. Next interval is going to go from -5, again parentheses, to 2. Would I include 2? Would I put brackets or parentheses? Now this time it's okay to put brackets because 2 is a 0 from the numerator and the inequality is inclusive. You see the difference? And then the last interval is from 2, which I'm allowed to include to infinity. Okay, I have to rewrite that so it looks nicer. There we go. Now let's test each of them, same way we did before. So between -infinity and -5, we could test with -6. And you're just going to plug it in for x into the rational expression. So -6 minus 2, that's negative. Divided by -6 plus 5, that's negative. A negative divided by a negative is positive. Is that what I want? Are positive numbers less than or equal to 0? No. So this is no good. Okay, what's between -5 and 2 that you would like to test with? Anything nice? How about x equals 0? That's so very nice. So 0 minus 2 in the numerator, that's negative. 0 plus 5 in the denominator, that's positive. A negative divided by a positive, that's negative. Does that interval work? Yes, it does. Yay. Lastly is the interval from 2 to infinity. What should we test with? 3? Wonderful. So 3 minus 2, that's positive. 3 plus 5, that's also positive. A positive divided by a positive is positive. Does that work? Remember, our inequality, we want values that are less than or equal to 0. So positive numbers are not less than or equal to 0. So this does not work. So for our final answer, I'm just going to list out the interval from -5, but I don't include -5 to 2. And we are done. All right, good. Next one, x minus 1 divided by x minus 2 is less than 1. Remember, we need a 0 on the right-hand side, or at least on one of the sides. Usually we put it on the right. So let's move that one over so we have x minus 1 over x minus 2 minus 1 is less than 0. And then I need to get a common denominator. I sure do. So the common denominator is x minus 2. So now we have here x minus 1 minus 1 times x minus 2 over x minus 2 is less than 0. And then let's clean up the numerator. So x is going to cancel. I have negative 1 plus 2, which just gives me positive 1 over x minus 2 is less than 0. So this is the inequality we're going to solve now. There's no zeros from the numerator. It's just a constant. And then x equals 2 is a 0 from the denominator. But remember, it's also a restriction, so I won't include it. So all I have here is sad little 2. So here's my two intervals from negative infinity to 2. I'm not going to include 2 for 2 reasons. The inequality is strictly less than 0, and it's a restriction, since it would make the expression undefined. Next intervals from 2 to infinity. Okay, what do you want to test from negative infinity to 2? You want to test with x equals 0? We can. Okay, now look at this. In the numerator, we just have a 1. So that's not going to change no matter what x is. That's a constant. So we've got 1 over 0 minus 2 is negative. So that means everything in this interval is going to make the inequality negative. Does that work? Yes, negative numbers are less than 0. So that's good. We want that. What about from 2 to infinity? Say you test with x equals 3. You have 1 in the numerator, that's positive. Divided by 3 minus 2, that's positive, which means everything in this interval is going to make the inequality positive. Does that work? No, right? We want it to be less than 0. So the solution is going to be the interval from negative infinity to 2. And that's it. Okay, nicely done. Let's take things to the next level. We've got x times x squared plus 1 times x minus 2 over x minus 1, x plus 1. So let's list the zeros. This would give me x equals 0. X squared plus 1, you don't get any real zeros from there. Look, x squared plus 1 equals 0 means x squared would have to equal negative 1, so there's no real zeros. In fact, think about it. Anything you plug in for x is going to make this entire factor positive. Even if you plug in negative 1 million, negative 1 million squared plus 1 is positive. Okay, so you basically don't even need to include that factor when you're testing signs. X minus 2, the 0 is x equals 2. And then here we get x equals 1. But remember, x cannot equal 1. That's a restriction. And x cannot equal negative 1. So I'm only listing 4 values on the number line. Okay, and then be careful not to include the restrictions when you write the intervals out. So watch how carefully I do this. Smallest one on there is going to be negative 1, yes? So we've got negative 1, 0, 1, 2. Ooh, so many intervals to test. Okay, so the first one is going to go from negative infinity to negative 1. Would I include negative 1? Yes or no? No, because it's a 0 from the denominator, which means it's a restriction. Okay, next interval is from negative 1, which we already said we don't include, to 0. Do I include 0? Yes, because 0 is a 0 from the numerator. And notice this inequality is inclusive. It says greater than or equal to 0, so we're including it. Next interval, from 0 up until 1. Do I include 1? No, because it's a 0 from the denominator. Next interval, from 1 to 2. Do I include 2? Yes, I do. It's a 0 from the numerator. Last interval is from 2 to positive infinity. Okay, here we go. So now we have a testing frenzy. So from negative infinity to negative 1, let's test with negative 2. So if I plug in negative 2 for x, that's going to be negative. I'm just going to skip x squared plus 1 entirely. Anything I plug in there is positive, so it won't make any sort of difference. Negative 2 minus 2, that's also negative. Then let's see here. Negative 2 minus 1, that's negative. And then negative 2 plus 1, that's also negative. Oh my goodness, we're so negative today. So 4 negatives, right? Just count them up. That's going to give us a positive value for anything in this interval. Are positive numbers greater than or equal to 0? They are. So that interval works. Moving on, let's test with x equals, how about negative 0.5? Remember, you can't use any of the zeros from the interval, even if it's inclusive. So don't even think about using 0. Okay, negative 0.5, x is going to be negative. Remember, we're skipping x squared plus 1. Negative 0.5 minus 2, that's negative. Negative 0.5 minus 1, that's negative. And then negative 0.5 plus 1 is positive. So everything in this interval will give us a negative value, but negative values are not greater than or equal to 0, so this one won't work. From 0 to 1, x equals, let's use positive 1/2. So if I plug in positive 1/2 for x, that's positive. Everything in x squared plus 1 is positive. 0.5 minus 2 is negative. Now let's move to the denominator. 0.5 minus 1 is negative, and then 0.5 plus 1 is positive. So notice I've got 2 negatives, one in the numerator, one in the denominator. They're going to cancel each other out. So everything I substitute from this interval is going to make the expression positive, and that's good. Positive values are greater than or equal to 0, so that's going to be part of our solution set. Okay, next one, from 1 to 2. Let's test with 1.5. I'm going to go more quickly now. So positive, 1.5 minus 2 is negative, 1.5 minus 1 is positive, positive. So everything in this interval is going to be negative, no good. And last one, 2 to infinity, let's test with 3. Positive, positive. Oh, we changed our mood. Now everybody's so positive. Wonderful. Positive. It doesn't always alternate this way. It depends. So be sure to test them. Don't get lazy and think, oh, it's always going to go plus, minus, plus, minus. I mean, sometimes, a lot of the times it is, but not always. Not always, people. Okay, so here we go. Let's union up all the ones that were positive. We've got that interval, the one in the middle, and the one on the end. So our final answer is going to be negative infinity to negative 1, union 0 to 1, union 2 to infinity. Okay, good. The funny thing about this process is you're going to use it later in math, even in calculus, and students tend to forget that this even exists, and they'll try to solve a rational inequality in a very illegal way, which maybe I'll talk about at the end, but the math police are just going to come after you if you attempt that, okay? Here we go, last one. 1 over x is greater than 5. So remember, we need a 0 on one side of the inequality. So I'm going to subtract that 5 over. So 1 over x minus 5 is greater than 0. And then remember, we need a common denominator. So now I have 1 minus 5x over x is greater than 0. So let's list the zeros from the numerator and denominator on the number line. Here, I would get x equals 1/5 as a 0, and then I have a restriction here, x cannot equal 0. Both of them go on the number line. 0, 1/5. Okay, good. So we've got the interval from negative infinity to 0. I'm not including it. It's a 0 from the denominator. 0 to 1/5. I'm also not including it because this inequality is strict, right? Strictly greater than 0, not inclusive. And then last interval is from 1/5 to positive infinity. Okay, from negative infinity to 0, let's test with maybe x equals -1. So plugging in -1 for x, I'd have 1 minus 5 times -1, or 1 plus 5. So that's positive. Divided by a negative, right? Because I'm just plugging in -1. So everything in this interval is going to be negative. That does not work because I need that expression to be greater than 0. Okay, what about from 0 to 1/5? 1/5 is 0.2, right? So if it's easier for you to think in decimals, you can just plug in 0.1. That's between 0 and 0.2. And then 1 minus 5 times 0.1. 5 times 0.1 is a half. So 1 minus a half is positive. 0.1 is positive. So everything here is positive. That's going to work. And then from 1/5 to infinity, plug in just anything bigger than 1/5. How about 1? So 1 minus 5 times 1, 1 minus 5, that's negative. Denominator is going to be positive. That's going to give me something negative. So that does not work. No way. So our final answer is just the interval from 0 to 1/5. Okay. I did mention I wanted to show you like the great error in doing something that maybe is okay with an equation. Okay, and let's revisit this example. X minus 2 divided by x plus 5 is less than or equal to 0. Say you just ignored this whole process and you thought, I'm going to clear out the inequality, which is not allowed. So here we go. Let's do, this is a no-no. Don't do this. Don't do this. So x minus 2 over x plus 5 is less than or equal to 0. In an equation, it's okay. In an equation, if you have x minus 2 over x plus 5 equals 0, you just have to remember in the very beginning, list your restrictions. So, okay, x cannot equal -5. And then when you multiply through by x plus 5, it's totally fine. You end up with x minus 2 equals 0. So you get x equals 2, and you're so happy. Okay, that's going to be a problem here. So say you try to multiply the inequality through, clear out the fractions. You're losing information about the rational inequality. Then you get x minus 2 is less than or equal to 0. So then you would think, oh, x is less than or equal to 2, which would mean your answer would be the interval from negative infinity to 2. That's not even close. Do you remember what our answer was? Hold on, I have to exit out. I can't even look at this. It's bothering me that much. Oh my goodness. Don't do this. Look back at what our original answer was for that problem. It was only the interval from -5, not including -5, up until 2. So you would mistakenly include all this. Why did you mistakenly include it? Because when you multiplied through both sides by x plus 5, you lost information. You lost the fact that that factor controls the sign of the expression. And that's a problem with inequalities. It's not a problem with equations because as long as you list the one restriction, you're good to go. But here you have to think of infinitely many values besides -5 that are affecting the sign of the rational expression. Anyways, it's a lot to digest, but just keep in mind, you have to deal with inequalities differently than equations a lot of the time. So don't just go into autopilot mode and solve an inequality the way you solve an equation. Think to yourself, what am I allowed to do? These things are highly temperamental. And then if you remember that and kind of hold yourself accountable, then you'll stop yourself from doing some silly things. Okay? Hope you enjoyed the video. It's going to be so useful, so please don't forget how to do this even after this class. And I'll probably link it in a bunch of calculus videos because you'll need it as a reference throughout your math career. Don't forget to give this video a thumbs up, subscribe if you haven't already, and stay tuned. We've got lots more with polynomials, finding their real zeros, finding complex zeros. It's going to be fun.